A relation between two variables can also be defined by an equation. The equation y equals x squared minus 2 defines a relationship between x and y. In this case, we're going to draw a graph in order to illustrate this relation. And we're going to use this table of values here, starting with x values going from -3 to +3, plugging each of those in to find a corresponding y. So if x is -3, plugging into y equals x squared minus 2, we would have -3 quantity squared minus 2, which would get me +9, since that -3, the whole thing is squared, so we do square the sign as well. +9 minus 2, which gets me +7 to fill in here. We'll go ahead and do this for all of the entries and find all of the y values, and then we'll have a set of points to plot. After filling in all of these entries, I have the y values 7, 2, -1, -2, -1, 2, 7, with the calculations done off to the side over here. What I'm going to do now is get ready to plot all of these points on my grid. So starting with -3, 7, then going on to -2, +2, -1, -1, 0, -2, 1, -1, 2, 2, and finally 3, 7. It looks like my shape is a parabola. And all I need to do now is connect the dots to get an approximate graph of the whole function. Okay, so we have our parabola, and we're also asked to find, based on this graph, the domain and range of the equation. Now, I'm going to choose to do the range first because I think it's a little bit easier on these parabolas. For the range, I'm going to want to find a smallest and a largest y value. So, starting with a smallest, it looks like right down here at -2, I have my smallest y value, and then I start going up from there. And I can see the arrows pointing up on the graph, and that tells me that my range is going to go off to +infinity as well. So my range has a smallest value of -2 and a largest value of +infinity. We can, of course, write this in set builder notation if we're more comfortable with that at that stage. Either y is greater than or equal to -2, or starting with the -2 and going all the way up to infinity. For the domain, I'm looking for a smallest and a largest x value. The thing about this parabola is that by the time we get to those arrows, they really look like they're mostly pointing up. But they're not entirely pointing up. So when I come down here to the x-axis, and I'm looking at it, trying to see if there is a smallest x value, that arrow that's pointing up is also pointing off to the left to some degree. And even though it's a gradual left, it does keep going forever, and it never gets to a point where it turns completely vertical. What that means is that, in fact, my domain does go infinitely far to the left. It's going to go off toward -infinity over here. The same thing then happens on the right. That other arrow, which looks like it's mostly pointing up, is also pointing a little bit to the right. And so when I try to find my largest x value, I'm going to experience the same thing, that this goes off to infinity. We also have everything in between represented, and therefore my domain is the whole number line from -infinity to infinity, or we could even just state all real numbers for the entire number line.